All right, hello everyone, welcome to my channel. So here we have a nice question. Okay, this question is from abstract algebra group theory. So it says that if A and B are any element of group G, this is a group G. Okay, so it's asking us then BA B inverse all squared is equal to dash. And so it says A here, then B this, C this, and that. So which one do you think should be the correct answer? If you look at it very well, if you are not careful, you would pick this. Alright, because of course, if I have A B inverse all squared, by normal mathematics, using your usual sets such as R, C, even integers, rational numbers, and all of that. So you know that you are allowed to open that power is distributive over multiplication. So if you distribute this, it should give you B squared, A squared, B inverse squared. But in general maths, where we have groups or sets that behave in different ways, is this really true? So the answer is what we are going to see. So first of all, what are you supposed to actually do? So you will start by interpreting what you are given. You have B inverse raised to the power of 2. So this is actually the same as B inverse multiplied by B inverse. This time around, we are keeping the binary operation silent. So we are using multiplication as the binary operation. Okay, so what does that mean? Now from here, you can see that this is equal to, if you open up this, you are going to have B inverse, then B inverse. So we have removed the brackets. Okay, so and after doing that, you will now follow the process of the properties of a group to now simplify. So what are you going to get? Now we are told that under group theory, that if an element is computed, whether let's use multiplication, by its inverse, that it is equal to the identity element. And so the whole of this will become identity element. So I'll have this. All right. So the next now is that we are also told that if any element is multiplied, remember we are using multiplication as a default name, by the identity element, that it is the same thing as the element. Okay, so if this identity element multiplies this A, you are going to have B inverse. Okay, and what will happen next? This is the same thing as BA squared, then B inverse. Now the question is, now I have B here and I have B inverse on the other side. Is it allowed to allow this B inverse to cancel this B? That is a very important or critical question. And you know that at this point, someone may do that and then choose C. But is that really true? And the answer is no. It's not always so. It is only true if you are in an abelian group. Assuming that the person that gave us this question said that this G is abelian. Abelian means that the elements can be commutative. That means I can turn this way, so that assuming I'm able to turn it, I can now have B inverse, then A squared. It is only when the element B is together with the element B inverse that it can turn into the identity element. But at this time, they are on both sides of A squared. So, and you are not told that the group is commutative, so you can't turn it. So what do? you are expected to stop here. So, and that is your correct answer, which is option A. So you can see that B is not correct. Of course, mathematical under group theory, which is the mathematical truth, except if you're dealing with a particular set where power is distributive. It doesn't happen in all sets, so you don't do it generally. So this is not true, and then this one also is not true, and this is also not true. But all of them are things that we are conversant with. Normally in math, if I have something like, let's say, x times y times x inverse, I can quickly say this will take away this and give me y. But that's when you are in an abelian group. The normal groups or sets that we are handling, such as the set of real numbers, the set of complex numbers, and all those. Then when you are in a set where you are not told, because the real numbers are abelian, complex numbers are abelian, but here we are not told whether this G is abelian, so you are not permitted to do that. Alright, so A is the solution. Subscribe to my channel. See you in another video. Bye bye.